Hi guys, in this video I'll talk to you about the whisker and box plot. The whisker and box plots are very important visualizations used in science. Box and whisker plots, sometimes just called the box plots, additional statistical context to distribution. And to understand this box plot, consider the following diagram. The box plot has been added to the circle graph that we've done before, and the box is divided by the median. Or you can take a look at this diagram, guys, and look at it as consisting of a box, and these are whiskers. Yeah, so this is the box and this is the whiskers. So let's talk about the box. The box will have a line inside the box, but over here it is just the line, the border line between the darker and that separates, like the border line that separates the different shades of the color in filling the box. So half of this median means that half of the values are above and half are below, so it's midpoint. And the box also indicates the lower and upper quartile. So this is a quartile is a quarter, and the quartile is 25% of the data. So this is the 25% of the data that lies below the median, and this is a 20% of the data that lies above the median. So, these are the border lines of the box, these defining the box. So we have the median, which is the line inside the box, and then we have the two left and right edges of the box. The one defines the lower quartile and one defines the upper quartile. And then we have the two whiskers. With the two whiskers, they extend to the extend to 1.5 times the IQR. I didn't define the IQR. The IQR is the inner quartile. So this is this area between the edge of the lower quartile and the edge of the upper quartile. 1.5 of this area is the extent here, and this is delineates the one edge of the whisker, and this delineates the other edge of the whisker. So the box also indicates the lower and upper quartiles, and then each contain a quarter of the values. The span of the box makes up what we know it as the interquartile range, IQR. And the whiskers extend to 1.5 times this IQR. So this area, this whole distance here from the upper to the lower is called IQR, and this is 1.5 IQR. So IQR value, or the maximum extent of the data. Any marks beyond the whiskers are considered as outliers. So this is how we define the outliers. There are different ways, guys, in data analytics that we define outliers. The first way is by considering the z-scores. Basically, z-scores relies on or based on the average, which is the mean, the standard deviation, or is it the standard deviation? Yeah, the standard deviation and the mean. So there is a certain way to compute the z-scores, and accordingly, if a certain with certain z-scores, I believe in the above 3 as a z-score is considered an outlier. But it also depends on the context. Always everything depends on the context. But the z-score is one way to identify outliers. The other way that you could also use to just verify your results and have a better idea of the data distribution is the box and whisker plots. So you can also use, with the help with the box and whisker plots, you can also identify possible outliers that maybe we're not sure whether to drop them or consider them or detect them out as outliers or not with the z-score. So with the whisker, with the box and whisker, it will help us better identify also outliers. So there are two different ways to identifying outliers. So statistically, we start with the circle diagram, then we start considering the outliers with the box and whisker plot. So now I'm going to show you how to do the box and whisker plot to consider creating this kind of box and whisker plot. So let's say that we have the data, the following example, the same as the example that we had in hand in the previous video, but just in case you're watching the videos at a different time, I'm going to just recreate the example here. We got the average. We're working with the average minutes to service per department. And instead of a bar, we did a circle, right? And then we said, you know what, this is so small, let's just stretch this down. And we also said it's maybe very boring without colors. And we also said, how about the details being the doctor? So we just dragged the doctor and added it to the details. And we also said, you know what, why don't we add just the here the colors and add a little bit of transparency variation. And then we talked about the jitter, so we added here a jitter. And then we found out that if these are still all lined up like this in the same line vertically, horizontally, sorry, and we want them to be spreading vertically, then we were like, you need to put computing as and the doctor, and then we now are ready to add the box plot. So you go to analytics and you just drag the box plot and you add the box plot, and it looks really awful. So this we've done something not fancy here. Let's just back and let me just to add a box and whisker plot, use the analytics tab on the left, drag the box plot to the view, doing this to the circle chart we considered previously, used to the following chart. Well, here we go. It didn't yield to the same chart here. Once again, troubleshooting. Okay, there's summaries here and there's this box plot. Let's check this guy. Okay, let's check what's going on. Data within 1.5 times the IQR, yes. Okay, I don't need this, so I'm gonna use the classic. So this is the classic if you want. Border is okay, all is okay. They maybe not hide the marks. Let's keep the marks. What I don't understand is this area over here. What happens if I get rid of the jitter? All is going well. Okay, now I see. So so it seems like the problem here, guys, is with the somehow I need to just let me remove it for now, the whisker. Yeah. And let's see why. Let's add the whisker plot again. And I think I've done something with the whisker plot. I should have kept it 1.5. So let me just edit it. Here we go. Edit. No, it is done fine. 1.5. of the data and the classic. I can put it modern if you want, so this will look a little bit more of shades. Let's add now the jitter and see what happens. Okay, all right. What happens if we use doctors here? Some span here happens. No, definitely not department type. Yeah, I wonder why sometimes it will act really weird. Okay. Upper whisker 15. As you can see here, I don't have a jitter. So it seems like we don't need a jitter. Let me check again here. We don't have jittering with the box plot. So I tried now with you guys, and seems like jittering doesn't work well with the box plot. So definitely a better scenario is here. I'm just gonna put the size in such a way that it looks more professional. So it seems like we just, as I've done it here, it seems like we would just not use the jitter, and also here in the slides we don't add a jitter. So I tried to keep the jitter, but no, it won't work well. So this is a box plot now, and it's on the modern, not the classic. If you want to edit it, you can just edit it and put it as, instead of modern, or you can actually change the color, so you can have it in different colors if you want. For now we can just keep it as is, and let's keep it with the classic classic form. You can change the colors of the whiskers and so on, actually in the format as well. Here you can have the fill more transparent, you see. So right now you can see that the fill is more transparent, and so on with the technicalities. The technicalities, you keep it as circle. You just, whenever you add the reference line, you just add the box plot. So today we use more of the analytics tab, adding an average line, which also the same as a reference line but average. We added also a box plot, as you can see. And right now, before I just leave this topic, let me just talk a little bit about the uses of the box plot. So the box plots helps us to see how to compare the medians and ranges of data concentrations of values. You see where the data concentrated in within the internal quartile, so the IQR. So you can see how the data spread is like. One is more relaxed than the other. You may also edit the box plot by right-clicking on it, as I've done, and just selecting edit. And this will reveal multiple options, including how the whisker should be drawn, whether only we have no outliers so far. So when I looked at the confidence interval before in the previous video, and I was talking about outliers, well, it depends how you're looking at an outlier. So within confidence interval of 95%, if you're looking at outliers for example, if you're looking at a regression and you're examining the error, the standard error, then within the standard error, if certain readings exceed a certain reading in the standard error, then this we might consider it as an outlier. In other data, also data sets, we use the box plot as a data, and or we use the z-score to detect any outliers, and then we can decide what to do with the outliers. Of course, there are different courses of actions to deal with outliers, and they are all very difficult to determine. It requires understanding of the context, the data in hand. Well, one of the options that you may take, and these are the most common options if you have a very big data set and you can afford let go of certain records. So you can drop the outliers. If you have a big data set, if dropping these records or these data points will not affect the behavior or will not intervene or impede the investigation using a certain analytical technique also. So you can drop the data points. You can also decide to smooth the outliers. So knowing the reason of the outliers will help you whether to delete the outlier or whether to smooth the outlier. For example, if you got a data set from a mall and you found out that the behavior, the usual, the normal behavior of any mall is for the shops to be buying and to be selling goods or services to customers every day. So on the revenue chart, you will find little surges, not sharp surges. But let's say that in some mall, you were working on a project with a certain mall, and it has happened to me, where there are surges, like big surges at the end of each quarter. And I was like, what is this? Why? Are they organizing any campaigns? Anything is happening? No, nothing abnormal. So we found out that this mall in particular has a store, and this store doesn't have any transactions happening all quarter long. It receives no money, zero money, and at the end of the quarter, there's a lot of money getting into that store, and this is causing the surge. And this store ended up being I'm not gonna mention the name, but it's ended up being the music store. If you go to a mall and you see music stores or stores that sells musical instruments, almost they're not selling all quarter long, but then they provide classes, and apparently students pay for these classes at a certain deadline and a certain day. So they pay in a certain day of a quarter. I don't remember if it was at the end of the month or at the end of the quarter, but there was dates, exact dates that where everyone will be paying the fees, and this will cause the surge in the revenue. In this case, we are obligated to delete this outlier because it caused the surge. Why we are obligated? Because its behavior is abnormal to the behavior of all stores in the mall. So we can't just say, oh, here's the data, let's use regression for prediction. We need to understand the data. We need to visualize the data. It should take you 1 month, or take your time, basically. Take your time to see the ins and outs of the data. Make sure the data can tell you a story. All the data is consistent. The whole data also makes sense. Even when you're doing regression, you cannot just get a data set for restaurants that belong to fast food restaurants around a university and then use it to predict sales and then use the same model, which is a great model actually, by the way. Let's say its accuracy levels are all high and its performance is superb, and then use this model for fine dining restaurants in Tokyo or Michelin star restaurants. The prices are different, the business model is different, the opening hours are different. So yes, even with analytics, you need to employ common sense, and the data should tell you a consistent story. So I am just talking about outliers now because We're talking about outliers in general and how to use the box plot for outliers. So it's important also to use multiple. I do that, but it's not important. Like, you won't see a book telling you you are required, but I think it is a good practice, and it has happened with me before that I use the z-score. But then when you use the z-score and you clear the data, you need to make sure that the data actually is now clean and doesn't have any outliers. But every time you run the z-score, you might still get outliers. When shall I stop? So sometimes the box plots just give you a real confirmation that you are going the right direction and you can stop. All right? Good. So having this said, guys, having this said, please make sure that the decision you make around outliers, if you're writing your thesis or presentation for your manager, that if you suggest to drop the outliers, you have a story on why. Either the technique that you are probably most likely going to use for answering a certain question or investigating the data will not be hurt, or will not require all the data being in chronicle order. For example, if it's a chronicle order is important, doesn't hurt that. Or let's say if the data set in hand is really big, so you can sacrifice dropping certain data points. Or if the outliers do not exceed a certain percentage. So some outliers are really huge, like the number. So in this case, you probably might consider other courses of action. What other courses of action we might consider? Let me give you also another example that you might enjoy listening to. Another example, lovely people, is when you have, for example, you're working still with the mall data set, and then you have certain days in the year are national holidays, but some of them, the 2nd of February, for example, in year 2018, let's say it is a Saturday. No, let's say it's a Wednesday, but it happened to be a Thursday in the year after. And let's say that it is a day off. So how are we going? And we need to smooth the data, or we don't want to drop certain data. Maybe this is not an outlier kind of example, but even if it's an outlier, let's say, let me give you an outlier also. Let's say that a certain outlier ended up being a weekday versus certain outlier ended being a weekend. In that outlier, we have a working week is 5 days. Let's say it's Monday to Friday, and the weekend is Saturday and Sunday. So what do? Do we average the 7 days a week and give the average, assign the average value to the missing dates, the outliers, like they are very surging outliers for a certain reason? And it is probably a campaign that we used to run, but we're not going to run again next year or in the future. It's the campaign is over. So what do? So in this case, the best course of action is to look at the behavior of the data, and most likely working days will behave certain way and weekends will behave a different way. So we average the working days of that week, of that specific week, and we assign the value to the outlier if the outlier is a weekday. Now, if the outlier is a weekend, we average the sales or the revenue of all weekends within 1 month. Yeah, within that month, so that we can assign it as a value. So you can see now, detecting outliers is something, and you might think it's the most difficult thing, but actually after detecting the outlier, what to do with it is a different story. So this is also one example. If it is a weekday, usually we average the weekdays and give the average number, or we average 2 days before, 2 days after, up to you. See how the data is behaving. or you could decide that if the weeks are not behaving similarly, and the days are behaving certain way, then you can average all Wednesdays of the month and give that missing Wednesday, or that outlier, a Wednesday that is an outlier, give it that average, just exactly how we've done with the weekends. So it depends. You need to look at the data, really. You need to examine the data. So this is why data visualization is the first thing I teach in my data analytics exercises and data analytics topics. All right, as with this, I will conclude this video, and I wish you all the best. I'll check the time left for today's class, and probably I will just make one more video for today before I guys let you go. So now with the assignment, I'm going to give you the circle before jittering, circle a chart with jittering, and the box plot here. Remember not to add a jitter for the box plot, and then I will see you for the histogram. So I'm going to give you one more extra recording. I'll show you how to create a histogram, and then that will be it for the assignment for today's flip class. I'll see you in the next video.